NCBM 0324, Section 1.5, Basics of Factoring Polynomials, Part 6. Let's practice some more. So for example 9, we're still factoring. Let's look at Part B. So I have x squared plus 16x plus 60. So let's figure out what our b value is, how we're going to get it, and our c value. So the b is the coefficient of the x, so it's the number in front of the x term, the middle term. So it's going to give me 16. And the c term, the last term, over here is 60. So without having to list everything, let's see if we can figure this out just by analyzing it. I'm multiplying to give me 60, but when I add them, I get a 16, 1, 6. Let's see. Well, 60 ends with a 0, so I'm thinking something with a 10. And a 10 times a 6 will give me that 60. Nice and positive, both will be positive, but maybe they're both negative, right? A negative times a negative will also give me a positive. That could be a possibility. Let's check these two to see if it adds to the right value. I want to add to be a positive 16. So 10 plus 6, when I add them up together, does give me that positive 16. Would my other values work as well? Let's check. So negative 10 plus negative 6, well, that gives me a 16, but it's negative. So while I have the right value, the sign is different. So it looks like my values that I'm looking for, that I'm going to use in my factorization, are 10 and 6. It may have been some other values, right? It may have been 2 times 30 maybe, right? If the different value for b was given. So it all depends on the relationship between the two. And the more you work with it, sometimes you start to see patterns and you get to the values a little bit faster. But it takes a little time, so no pressure if it doesn't come right away. So I have x squared plus 16x plus 60 is equal to, let me set up my parentheses. So x times x is what gives me that x squared, right? And that's important. That's why we're looking at just coefficient of 1, leading coefficient of 1. That's how we know it's always going to be x times x because of this. Then my integers that we found were a 10, a positive 10, and a positive 6. So it looks like x plus 10 times x plus 6 is the factorization of my expression. And if I check it, if I practice my FOIL, my distributive property, yes, it would come out to be that expression. Let's look at part C. What do we have in part C? I have another x squared minus 6x plus 9. X squared minus 6x plus 9. So let's figure out the b that we're going to need, the c. B value is in front of the x, right? Not the x squared, just the x. So that's a negative 6. Last value is our c, that's the 9. So I'm looking for two numbers multiplied to give me a positive 9. But when I add them, I get a negative 6. I'm going to use the signs to help me here. Because the multiplication results in a positive, but the addition results in a negative, that's telling me that my numbers are both going to be negatives. That's the only way the multiplication will turn out to be a positive. Negative times a negative is a positive. And when I add the numbers, it stays negative. Well, then let's think about the values. So multiply to give me 9, add to be a 6. Well, the only way to get 9 is 1 and 9. Well, that's not going to add to 6. And the other way is 3 times 3. And 3 times 3 is 9. 3 plus 3 is going to give me that 6. So those look to be my values. Multiply them. I get a positive 9, which is good. Add them. I get a negative 6, which is what I want, right? So we're good. We have our values. 3, negative 3, and a negative 3. So let's write our factors then. We have x squared minus 6x plus 9 parentheses, x times x, this gives me that x squared. And by the way, we will see later on in the semester what happens if our leading coefficient isn't 1. We'll get to that eventually. For now, we're just doing the basics. And then my integers that we found were -3 and -3, which is interesting. They both came out to be x minus 3. In fact, when this happens, when I have the same factors, x minus 3, x minus 3, I can simply write it as x minus 3 squared. Remember, we did this in our function section, right? If I have a square, that means I multiply it by itself. So then if I'm multiplying by itself, I can then write it as a square. I can use that in the other direction. So x squared minus 6x plus 9 is simply x minus 3 squared. One more. Example D. We have x squared plus 6x plus 9. So similar numbers. Our b value this time is a positive 6. Our c value is a positive 9. So that's telling me something. The signs are helping me to eliminate some possibilities, concentrate on others. Because I multiply to give me positive, and when I add them, they're both positive, I know both of my numbers should be positive. Right? It's the only way to add to give you a positive if your multiplication is also positive. And then I'll think about the values. Multiply to give you 9, add to be 3. Well, it looks to, sorry, add to be 6. That looks to be 3, right? I gave the answer way too early. So they multiply to give you 9, and they add to be the 6. So we're good. Let's write out the factors. All right, we have parentheses x times x. Our integers we found were plus 3 and plus 3. And once again, these are the same, so I can write it in a more condensed format, x plus 3 squared. Now these last two were pretty unique because the factors came out to be the same on both values here. In fact, when that happens, we have a name for them. These are called perfect square trinomials. Trinomials. These are perfect square trinomials. And there's patterns to it where I notice this is double of my term here. This is double, right? We can kind of start to put some observations down. But in general, these are referred to as perfect square trinomials.